Hey guys, we're talking about some more properties today. I have some examples of some properties here, and I intentionally left off the names. I put some examples up, and I want you to try to figure out what they are. So I'll go through them really quick. If you want to pause and try to take a guess at them or write them down first, feel free, and then maybe we'll reveal some answers. So let's take a look. We have 5 times 0 equals 0. We have another example, 0 equals 12 times 0. Another set of examples we have here, different property. We have 12 equals 0 plus 12. We have 9 plus 0 equals 9. Another set, our blue set here, we have 32 times 1 equals 32. And we have 8 equals 1 times 8. Our last example, which may be a little hard to read, I'll stay out of the way for a second. We have 2/3 times 3 halves equals 6 over 6. And 6 over 6 equals 1 whole. And we have another example here. We have 1/5 times 5 equals 1. Take a second to jot these down, to come up with a guess as to what you think the property names are that match up with these examples, and we'll move on. 1, 2, 3. Hopefully you paused, ready to turn them over. Let's reveal some answers here. Oh, that didn't work. Blooper reel. Put that on the blooper reel. Okay, so we have our properties listed here. The two properties that we have at the top, 5 times 0 equals 0 and such, are examples of the multiplicative property of 0. Anything times 0 always equals 0. Easy stuff. We talked about the additive identity property in class. Basically, if you add 0, goose egg, the symbol for nothing, to a given number, you won't change the value of that number. So you're identifying that number twice. 12 equals 0 plus 12. And the other example is also appropriate if you can see it. The next example we have are centered around multiplicative identity, and that's a little bit hard to see, so let me fix that. Mess that up a little bit. So 32 times 1 equals 32. So basically, anytime you multiply a number by 1, you will not change the value of that number. And that's the basis for a lot of the work that we do in the first part of the school year when we talk about simplifying, when we're dividing the numerator and denominator by a given factor. Like if I have something like 10 over 12, and I divide both of those numbers by 2. Well, mathematically, I am not dividing both values by 2. I'm dividing 10/12ths by 1, because 2 divided by 2 is 1. So we see this very often, and we should already be kind of familiar with that. And if we make that connection between the old math and the new math, it makes a little more sense. So multiplicative identity, anything times 1 equals itself. Multiplicative inverse is probably the most difficult of the 4 that you see up here. And when we talk about inverses, we're talking about reciprocals. We're talking about flipping a fraction, for instance. If I have 4/5 as a fraction and I asked what the reciprocal was, you could flip that fraction over and 5/4 would be the reciprocal. And by multiplying those two values, I get a product of 1. That's the basis for reciprocals and for the multiplicative inverse property. Two numbers or two values multiplied together will yield a product of 1. And that shows right here, 2/3 times 3 over 2. Multiplying them together, you get 6 over 6. Well, if you know anything about simplifying fractions, 6 divided by 6 is just 1. Or by finding a number that divides both into 6 and 6, which would just be 6. So the answer would be 1. Same thing goes for 1/5 times 5 equals 1. I could turn this 5 into an improper fraction by putting a 1 underneath it as a denominator, and that would show that flipped fraction concept that I was talking about previously. So basically 1/5 times 5 equals 1. It does show the multiplicative inverse property. Okay, these are some of the easier properties that we talk about in SWL 6.19 Virginia. The other properties that we talked about previously, commutative, associative, and distributive, are found in another video. I encourage you to take a look at that and review those skills for yourself and make yourself a little stronger at those. And if you have any questions about this, any feedback you can give about this, don't be afraid to bring it up in class. Take some notes, ask questions, get better. Keep in mind that this is pretty much a vocab SOL. It's a concept SOL. You have to know a concept, and we're not working with a lot of calculations. It's just a matter of recognizing things when you see them. Have a great day.